Hello everyone, welcome to the ninth session on Semiconductor Fundamentals. In this session, I will be discussing about Varactor Diode. A Varactor Diode, also known as a Varicap Diode and Tuning Diode, is a PN junction diode which acts as a variable capacitor under varying reverse bias voltage applied across its terminals. The schematic symbols representing a Varactor diode are shown in figure 1 here. Note that the schematic symbol appears as a hybrid of a normal diode and a capacitor. Therefore, Varactor diode can be treated as a specially designed semiconductor diode whose capacitance at the PN semiconductor junction changes with the change in voltage applied across its terminals. It is mainly used to replace variable capacitors that need to be operated mechanically for changing the value of capacitance. Let us now look into the construction of a Varactor diode. A Varactor diode consists of P-type and N-type semiconductor layers sandwiched together with the N-type layer attached to a MESA structure. The table-like structure what you're looking at here is the MESA structure. For conventional diodes, the P-type and N-type semiconductor layers are uniformly doped with impurities to improve the conductivity. But in the case of Varactor diodes, the concentration of impurities near the PN junction is very less and it gradually increases as we move towards the layer's other surface. A gold-plated molybdenum stud is connected to N-type layer via a MESA structure and it acts as the cathode terminal. This is the cathode terminal here. The P-type layer connected to the another gold-plated molybdenum stud via the gold wire acts as the anode. This is the anode here. Except for some portion of the molybdenum studs, the entire arrangement is enclosed in a ceramic layer. The rectangular structure what you're looking at is the ceramic enclosed layer. The P-type and N-type layers of the Varactor diode are made up of silicon or gallium arsenide depending on the type of application for which it is being used. For low frequency applications, silicon is preferred, and for high frequency applications, gallium arsenide is preferred. Now let us continue to understand the working principle of the Varactor diode. To learn how a Varactor diode works, we need to first understand the working principle of a variable capacitor. A capacitor consists of two conducting surfaces separated by a non-conducting dielectric medium, and this is shown in the figure here. When one of the surface is connected to the positive voltage and the other to the negative voltage, because of the attraction between positive and negative carriers, positive charge carriers accumulate on one of the surfaces and negative charge carriers accumulate on the other. The amount of charge so accumulated is termed as capacitance of the structure. If we reduce the gap between the two surfaces, the force of attraction between positive and negative charge carriers increases, and so more charge carriers accumulate on the surface. This in turn increases the capacitance. The opposite happens when the surfaces are moved away from each other, that is, the capacitance decreases. A variable capacitor has a mechanical arrangement which allows us to change the gap between the surfaces, which effectively changes the capacitance itself. Now, let us come back to the working of the PN junction diode. The P-type layer of the diode is filled with positive charge carriers and the N-type layer with negative charge carriers. Near the surface of contact between the two layers, positive and negative charges diffuse and neutralize each other. This region is known as the depletion region. The purple colored structure what you're looking at here is the depletion region. No further diffusion of charge carriers through the depletion layer is possible unless an external voltage is applied. So, the depletion layer effectively acts as an insulator. The width of the depletion layer depends on the voltage applied across the P and N type layers. If a forward bias voltage is applied, that is, the positive voltage is applied to the P type layer and negative voltage is applied to the N-type layer, the width of depletion layer decreases. And above a certain voltage, it completely disappears, and this is shown in the figure B here. If a reverse bias voltage is applied, that is positive voltage to the N-type layer and negative voltage to the P-type layer, the width of depletion layer increases, and this is shown in the last diagram, which is figure C here. Simply put, the width of the depletion region can be changed to a required value just by adjusting the voltage across the P and N-type semiconductor layers. So, by now you must have observed the similarities between the capacitor and the diode in reverse bias. The depletion layer in the diode is similar to the dielectric medium in a capacitor, which acts as an insulator and prevents the flow of charge carriers from one side to the other. So, when reverse bias voltage is applied across the diode, respective charge carriers accumulate on either side of the depletion layer. This makes the diode acquire some capacitance, and it is termed as the junction capacitance. A Varactor diode is specially designed to enhance this ability to store charge carriers when reverse bias is applied, thus allowing it to act as a capacitor. The junction capacitance is inversely proportional to the width of the depletion layer. That is, if the width of depletion layer is less, the capacitance will be more, and vice versa. So, if we need to increase the capacitance of a Varactor diode, the reverse bias voltage should be decreased. It causes the width of depletion layer to decrease, resulting in higher capacitance. Similarly, increasing the reverse bias voltage should decrease the capacitance. This ability to get different values of capacitances just by changing the voltage applied is the biggest advantage of a Varactor diode when compared with a normal variable capacitor. Let us now continue to understand the characteristics of a Varactor diode. First, let us understand the figure B that is shown here. The graph in figure B illustrates the relation between the magnitude of the reverse bias voltage of a Varactor diode and the magnitude of the junction capacitance. You can observe that the junction capacitance of a Varactor diode is inversely proportional to the reverse bias voltage applied. Also, because of the difference in the way impurities are added to the P-type and N-type layers, the capacitance of a Varactor diode is always higher than that of a conventional diode. Also, coming back to the diagram A here, this is nothing but the VI characteristics of a Varactor diode. This anyhow is pretty similar to that of a PN junction diode, and I am going to skip the discussion because you can refer to one of my previous sessions to understand this particular characteristic curve. The exact magnitude of junction capacitance of a Varactor diode is calculated with respect to the capacitance at zero bias condition, forward bias voltage, and the actual reverse bias voltage applied across the junction. This can be given by Cj equals C0 into 1 plus Vr divided by Vb whole to the power minus n, where C0 is the capacitance at zero bias condition, Vr is the actual reverse bias voltage applied across the junction, Vb is the forward bias voltage applied, and n is a constant and varies depending on the way P and N layers are doped. The value of n lies between 0.5 to 0.33. The value of reverse bias voltage Vr should be below the breakdown voltage, above which the value of the capacitance Cj equals 0 because of the breakdown of depletion region and the free flow of holes and electrons. Now we move on to the advantages and disadvantages of the Varactor diode. I'll start with the advantages first. It has small size and portable, so you can use it in circuits easily. It is reliable, so you can use it as a variable capacitance. It is very low cost, thus it can be used in various electronic and electrical applications. It generates very less noise as compared to other PN junction diodes. Also, it has very low power loss because Varactor diode produces very low noise. Coming to the disadvantages, these type of diodes are specially designed to work in the reverse biased mode. Hence, they are not useful when operating them in forward biased mode. Lastly, coming to the applications of Varactor diode. Owing to the special property of varying capacitance with varying voltage, Varactor diodes are mostly used in frequency modulation or tuning circuits where the value of capacitance determines the output modulation frequency. Some of the other applications include automatic frequency controllers, ultra high frequency television sets, high frequency radios, frequency multipliers, band pass filters, and harmonic generators. Well, with that, we come to the end of this session. To summarize, this session provided brief introduction to the Varactor diode, followed by its construction, working principle, VI characteristics, limitations, and applications. I hope that you found this video informative. Thank you for watching. Have a good day.